Eu ponho lá em cima, não tem problema.
Põe uma dessas, olha, o último que vier.
Sim, só um único.
So where are all our keynote speakers?
It's coming. I want to take this opportunity to ask all the team that put this conference together to come here so we know who to blame for this fiasco. Come on, go. By order of no order, we have the main person behind this, Rosanna, which is the mastermind of controlling every penny, every detail, mind-boggling. Then we have the creative mind of all the beautiful papers and presentations and all, which is Fernanda. Then we have the man that is receiving and taking care of all the internet stuff that is mind-boggling these days, which is Ricardo. Then we have Felipe, and we have Pedro that have been supporting us with 500 other little details. So thank you very much, guys. This would not have been possible without you.
Okay. Ma'am.
And now it's up to you.
They will come. Okay. Good afternoon, everybody. My name is Maria de Lourdes Antunes. I work at this place at LNEC. I have to say that I know George even longer than Jeffrey. So anybody, okay. Yes, I'm not sure this is good or bad, but yeah, that's life. So thank you for being in this last session. We are starting with a presentation from Ana Cristina Freire, who will present some of the developments done here on evaluation of a pavement section with asphalt rubber. And then after that, I will call our distinguished panelists to come and join me and have a chat. Okay, Ana Cristina, please.
So, good afternoon to you all. Thank you very much to be here at the last day of the presentations. The last presentation, but not the least, hopefully. I bring you here some results of a study that is going on still regarding temperature influence on mechanical behavior of a road pavement RAR test section. I will present you, the scope of the presentation has to do with introduction, the study that was developed regarding the pilot section, the materials, the mixture characteristics, the test methods that were applied at this moment, and which results are presented here, the results and discussion, and some conclusions and future studies. So to present you what we are still developing at laboratory. Well, just a brief introduction. Everyone here is related to pavement, road pavement, circular economy, etc. But let me present you and say something about it, just to have some connection with all the study. As we all know, major functions of road pavements are to provide proper surface to support traffic loads and fulfill functional requirements, and of course structural one also, and suitable and safe conditions during all service life. So the main goals of our study regarding development and validation of alternative and innovation materials intend to give some answers to an issue that is presenting to our lives in the last, let's say, 10, 20, 30 years regarding the resource scarcities, environmental sustainability, to explore proper alternatives through the application of recycled aggregates, industrial waste, biomaterials, polymers, in order to protect all the resources, finite resources. That's the issue. So we have to promote major environmental advantage, reducing, that's the main goal, reducing the resources consumption, and also, we have been talking about this all these 3 days, lowering greenhouse gas emissions. So we arrived to RAR, the react and activate rubber, that it's composed of neat soft bitumen, a fine grained chrome tire rubber, and active fillers. That was part of the mixture that we characterize in this study. So the pilot section that was constructed here at LNEC in 2017, perhaps some of you were here during the conference organized by ERF. If you remember, the test section was done outside by Tecnovia at the moment. It is a thin asphalt overlay, and the mixture was produced at the continuous drum mix plant at Rio Maior and was transported, laid down and compacted here at LNEC. So, and here we can see some moments of that, that application, compaction here. You have seen it. It still has, and we expected that it happens, a very good aspect. All of you can do visual inspection here. And these were the materials that compose the mixture. Here we have the job mix formula. It has 77.2% of a pen grade bitumen 5070, RAR-X 3.8%, and also some fractions, different 3 fractions of aggregates. Those are the characteristics, the grading of the mixture. It was a SMA11. And here we present also some characteristics that were provided by Tecnovia during the formulation of the mixture that was applied in the test pit. You have the density, the air voids, the binder drainage, and also the permanent deformation behavior that it's done with the European standard that has to do to evaluate the permanent deformation characteristics. All of it, all the mixture has a very good behavior and comply with specifications that are applied in Portugal. So we, at that time, in 2017, we extracted a slab, a big one, that was put it in our laboratory under controlled temperature, room temperature, and after these years, and intending to develop the study, we saw it in small pieces to characterize in the laboratory, to evaluate the mechanical behavior of the mixture. So what did we evaluate? The stiffness through the 4-point bending test at different frequencies from 0.1 to 30 Hertz at constant strain and through under 3 temperatures, 10, 20, and 30 degrees Celsius. Of course, we also evaluate the fatigue behavior on the same apparatus with the 4-point bending test under controlled strains and at 20 degrees Celsius. Of course, these tests are standard tests according to European standards that are referred here. So, our intention was to evaluate not only the mechanic behavior on an absolute approach, but also to evaluate the behavior of our mixture, the SMA mixture with RAR under different temperatures conditions. And here we can see the results for stiffness under the different frequencies, but also under different temperatures, 10, 20, and 30 degrees. Okay, you can see the pointing. As major conclusion, first conclusion, we can see, of course, and we expected that temperature influences the behavior, the stiffness behavior of the mixture, and we have, let's say, better behavior for lower temperature. But this is on an absolute analysis, only for our mixture. We also have the phase angle that we can obtain from the test, laboratory test, and that was done under that conditions. And of course, related, we see that lower temperatures give us lower phase angle. But just to have a better analysis of our results, we compare the results with a traditional mixture. AC14 surf, let's say an asphalt concrete mixture applied as wearing course, that it's usually applied here in Portugal, and that is a kind of mixture that we have a lot of results, a lot of experience, and we already know or expect a certain type of behavior. Here we compare under two frequencies of testing. This one, it's more related to the frequency that we apply to our samples can be related to the velocity of the vehicles that go on the wearing course, and this one is more or less to 60 kilometers per hour. And here, comparing the results, the conclusion is that for the different temperatures, the stiffness of the RAR mixture, it's better than the one presented by the asphalt concrete mixture. So we have here, of course, that in Portugal, let's say, you compare these results to the Portuguese characteristics and specifications. And for us, it is important and it's better to evaluate, let's say, what happens to 30 degrees. You see today the temperature we have outside, and 20 degrees. Let's say that it's an average temperature that we can have. So we see that there is a considerable difference, having a better behavior for the RAR mixture. And of course, we also performed the fatigue law for the RAR mixture, and it is here our fatigue law, and we found that the value that we obtain, we are going to compare it with those obtained to the traditional mixture, and this one is much better. So it resists better to fatigue conditions, to that kind of solicitation than the traditional one. So just some conclusions. We can say that the incorporation of RAR in the mixture can contribute to environmental sustainability, and promotes, of course, circular economy principles. It's a material that we all know that it's easy to storage, transport, and incorporate. And for the study that it's going on at this moment with this mixture that it was called thin gap with RAR-X, we could see that the stiffness models decreases with temperature increased, presenting what the conclusion we can give a significant lower sensitivity to temperature variations when compared with our conventional mixture. And we can also conclude that it presented an improved thermal stability. Regarding the phase angle results, they confirm that viscoelastic behavior consistent with enhanced performance. So our mixture showed a better balance between stiffness and flexibility across the test temperature that was performed. And also here regarding the fatigue law that we presented before, comparing with the asphalt concrete conventional mixture, it shows a superior fatigue resistance and extended service life potential. So a conclusion that we can give is that this kind of mixture with RAR-X can contribute for a long-lasting pavement, reduce maintenance needs, and have a more resilient infrastructure under climate and traffic conditions. So what are we what kind of tests are we still doing, and which kind of aspects we still need to evaluate and study? The long-term behavior of the mixture, the multi-recycling of the mixture. It's very important that when we add new materials, alternative materials, different from those that we are used to apply for 30 or 100 years, we have to evaluate the multi-recycling potential and possibility so that in 10 years or 20 years we can produce new mixtures with the material that at this moment is applied on the roads. We also intend to evaluate the life cycle assessment and life cycle cost analysis of the mixture and how since the production until the application and the recycling again. So thank you very much.
Thank you very much, Ana Cristina. Do we have any questions for Ana?
Not here.
Take this one. You can always.
Thank you. Thank you. That was a very nice presentation. I have a question about this changes between temperature. So if you are
Between?
when you showed different temperature and different frequency, 1 hertz versus 10 hertz and so forth, did you look at the extent of change between scenario? I know the plot you showed us, it shows like at higher temperature, 3 different temperature, 2 different frequency. But how
More than 3 frequencies. From 1 to, we go through 0 frequencies, so 1 hertz to 30 hertz.
So different frequencies. Did
Yes.
you look at how rubber modified asphalt responds to change of frequency compared to the non-modified one? You showed how it's higher or lower,
Yes.
but the change will be a response to extreme weather or changes in climate, all those things that you
We have here, sorry. Here it is always the same mixture, of course, and here you have the response for when we perform the test under different frequencies, but over here, but all this test was under 10 degrees Celsius. So we can compare for the same frequency and the different temperatures. So we can see that the behavior, but it's always the same mixture. Here we don't have results for the asphalt concrete mixture as a reference.
So that if you, I guess you have all the data, so it would be nice to take another look.
Further studies, it will be presented.
How sensitive the
Yes.
two are, and then we can report the sensitivity to temperature
Yes.
or frequency change.
Yes.
Very nice research.
This is just a summary. Thank you.
Any more questions? Well, if not, I think we will start with our panel discussion. First of all, thank you to George Way, who is here with me and will definitely enlighten our panel discussions. And I would, for those of you who don't know George, I don't think there's anybody, but anyway, he served for 35 years in Arizona DOT, Department of Transport, and he's a pavement management engineer and other pavement design. Sorry, And of course, now most importantly, is chairman of the Rubber Asphalt Foundation. Yes. And he's joining here our panel. Thank you very much, George. And now I would call the remaining members of the panel using the order that you showed in this conference. So first of all, Dr. Shakir Shatnawi. He's president and CEO of Shatec Engineering Consultants. He has a lot of experience with asphalt rubber, and he came here, for those who don't remember, to share some of his experience with asphalt rubber in California. What? Okay. So, Shakir, wherever you want.
I'm here.
Yes, thank you very much. Applause for. Okay, next in our panel's keynote speeches, we had Professor Krishna Biligri. I hope I am saying the name right. Okay, Professor Biligri is an internationally accomplished academician with over 20 years of combined research, teaching, and administrative experience in almost all over the world, India, USA, and Sweden. And he's currently a professor of civil engineering, civil and environmental engineering at the Indian Institute of Technology, Tirupati. Thank you very much. Right, our next speaker is Professor Camille Kalous. He's a professor who comes from the School of Sustainable Engineering and the Built Environment at Arizona State University. And he's the undergraduate civil engineering program chair and fourth professor of pavement engineering in the School of Sustainable Engineering and the Built Environment, also an affiliate, which is an affiliate faculty of the School of, again, Sustainability, and founder, past director of the National Center of Excellence on Smart Innovations. Thank you. Okay, next is Professor Zamping Yu. He's not here? Okay. He was next, but he's not here. Okay. So I welcome now Professor Ellie Finney, from which spoke today in the morning session. Ellie is an associate professor. Oh, first of all, let's thank her. Ellie, come to this side. Don't sit in the small chair. You have a big one for you. Okay. Yes, of course, she deserves it. She's an associate professor at the Arizona State University and an invention ambassador at the American Association for the Advancement of Science. And additionally, she's a Fulbright scholar at Aalborg University in Denmark, a senior sustainability scientist of innovative built and a senior sustainability scientist at the Global Institute of Sustainability and Innovation. Thank you very much, Ellie. Okay, we still have one more. Professor Kevin Wang also was here this morning. He's not
Here, but I don't know where he went. Oh, yes. There he is.
Ah, yes.
Kelvin.
Come here, please. Just in time. Very good timing. Welcome to our panel. So Professor Wang is a professor of civil engineering and director of the Western Transportation Institute at Montana State University. We all heard very interesting presentation on AI, on pavements, and we look forward to hearing a little bit more from you. Okay, well, thank you very much to you all. So just to remind us, we had 6 very inspiring keynote lectures. which addressed different stages and aspects of asphalt pavements developments. And as you all have seen with very much interest, I'm sure, they have shown them some proven solutions of using asphalt rubber and some actual, real, long-term performance of this kind of material. Some recent and ongoing developments, and quoting Professor Camille Kalouche, some pathways for tomorrow's innovations. So thank you once more for your lectures, and we are all looking forward to to hear more from you, and this is why we are here. So maybe I start with a question, and then. Okay, I got one here. So I think, well, some of you who are here have shown some very interesting results of many years, which is impressive, experiences with asphalt rubber in California, in Arizona, in India also, and also in using accelerated testing and service conditions, as I said before, and proves that it can really lead to a longer life and a considerable saving in material consumption, even in emissions also, presently. But this is not widespread. There are, even as far as I understand, even in the States, there are some states which use more asphalt rubber and others less. In Europe, we also can see that there are countries where you never hear about it. Why? Why is that such difference? Is it climate? Is it all the tires go for recycling in one area and not in the other? What's the problem? Can anyone give a view about it? I'm sure, well, the three gentlemen on my left can have some views about it.
Yes.
Yeah.
Any of us, all of us.
Yeah, all of you. Well, then just go one by time, one each time. Okay, you start.
Okay. It worked. So basically,
Is it on?
yeah, it is on.
Okay.
In the United States and elsewhere, even in California, the implementation of new processes and innovations takes difficult steps to get to the final stage. And that's because of many times political reasons, objection from certain market shares that can be influenced. It's all about the profit. Do you hear me? Okay. I will have to repeat. 2 inches? Okay. So I have to stay within 2 inches here from the microwave. Actually, I can hear it myself. So the implementation process is difficult. It takes a lot of effort. It requires a champion from each agency to actually implement it. If you don't have champions, it is difficult to implement. Because there's a lot of different lobbying for different interests can stipend the progress of implementation. That's my experience. My experience in California, there are market sectors, industry, that can have a lot of pressure on political entities within the agencies. They exert a lot of pressure to prevent and slow down the progress of implementation. That's one thing. The other thing is ignorance. People are used to doing the same thing over and over again, and they're very comfortable with that. So, and people just, many people don't like to actually take risks, because there are risks with new processes, because you need to create some experience from nothing, some states or governments, because you're going to get the contractors with some experience, and those contractors who've never done asphalt rubber and they're used to conventional processes may even themselves resist because they're worried about failures. And many times they want guarantees that they're not going to be penalized for their mistakes. So there are many, many reasons. Maybe other people can actually, provide other input.
I mean, I agree. I think I used a couple terms in my final thoughts in the closing in my talk. And I mentioned that we don't need any more proofs. We've been proving for the last 25 years, at least for this conference series, right? And you can go even beyond that time. And really the challenge is the mindset of people, public policies. How do we change that doing business as usual that you mentioned? So I kind of agree, but it'll be interesting to see if there are some potential breakthrough, how we can change the mindset of people in accepting new technologies and accepting change. So again, that is, I agree with what Shakir mentioned. I think there is a lot of, setbacks is driven by how people accept or are willing to take a risk. And George Way is sitting here, but when he was at the DOT, he was one of the biggest risk takers as a public figure. He tried things, and he always wanted to say, and then when things failed, he doesn't look at it as a shame. He looked at it as a positive, lesson learned, let's move on to the next project. So I think this is the type of issues that we need to take us in this room forward and maybe stop proving things. Let's just start addressing those issues.
Do you want to say something?
You want me to say something? Is this on? Yeah, it's good. Yes, I was blessed when I was with the department in that we had a very good leadership team while I was there for many years. And when something was brought up, like a new idea, our management was not of a mind to just ignore it. They were of a mind to ask, why not? Why can't we do that? What do we have to? What resources do we have to have? And I'm reminded of a colleague of mine who passed away many, many years ago, just a short story here. And his first project was to improve the skid resistance of roadways to make them safer. We had a lot of lawsuits in those days, people getting injured or dying because our roads were very slippery, and we didn't have any way of checking them at all. We could not afford an ASTM skid trailer, interestingly enough, the standard. So we wound up getting something called a mu meter. It was used for airfields. We adapted everything for it, and he worked on this continuously for 2 or 3 years. Eventually, he got a national award for his work that he did because he came up with something where you could come up. I know Kelvin talked about the difficulty of calculating friction, but he came up with an empirical method where they actually took molds on the surface, and they took those molds. And besides testing with the tester, the BPR tester,
the pendulum,
the pendulum on surfaces, then he would also mirror them, and then he would say, what is that value? And from this, he created many, many excellent ideas and did tremendous research. My point is, though, number one, we did it in-house, number one. Number two, we did it with very little resources, okay? But we were able to do it because our management was not micromanaging. They said, John, and his name was John Burns, this is your task. You figure it out. We can't give you much money. We'll give you what we can. You're going to have to use your brain to do this. And he did an extraordinary job. And I helped him with the math. I'm maybe a little bit more of a math guy than so forth because I'm a chemical engineer. and he was a civil engineer. And, we get trained a little differently. No offense meant to anybody, but, it's just the way we are. And he was a great innovator. I mean, John was. And he passed that on to me. I mean, I didn't know much at that time. Sometimes I don't know much now either, for that matter. I listen to Kelvin, I'm going like, I don't know anything for that matter. But yes, I had a great management team above me. we didn't have a lot of resources, but we had this inspiration that what we were supposed to do was something good for the roads, but ultimately good for the public. That was the most important part of all. We were supposed to be doing something good for the public. That was our role. We had to make not only good roads, but safe roads. And so he did a tremendous job. And eventually, we had highways with exceedingly high skid resistance because we adopted seal coats, we adopted open graded friction courses, we tested annually as much as we could. We kept records. Anything that had a low skid resistance, we told management, the maintenance, to put a sign up, slippery when wet, and then, we would program a project to fix it. What I'm trying to say here is it was a very good climate at that time internally with that. And if you don't have that, if people just don't want to listen, I mean, there are people in the world, and especially in state government, who just, as he said, and I mirror what he said, they just don't want to do anything. Their role is just to be there, basically, but not to advance anything. And there are lots of reasons, political reasons, so forth. I'm taking up too much time because I think other people need to. I would particularly. Oh, okay.
Yeah.
I particularly would like to hear what Krishna has to say, because he's in a spot where I believe he has a similar situation I had at ADOT. Maybe it's not perfectly the same, but I think he has the support of the people above him, the people who count, the decision makers, we used to call them. And I think they're in line with what he is doing and giving him a lot of freedom to experiment, to try things. I love the thing he said about all these, he called them waste products. I agree with Ellie. They're never waste products. They just haven't been, we haven't figured out how to use them properly yet, but they're there. They have value. Everything has value. And I like the way you're going about it. So I'd like to hear what he has to say.
Yeah, so it took 23 years before there was a circular from Government of India. Now, there are three things, I think. One is imminence of research to practice. That is still not there yet. We haven't gone to that level. We have been in the lab. We have not gone to the field yet. Again, I still believe in fundamental research. We have to do that, but it also has to go to the field practice. That was still not there in India for 23 years. They just took the technology from elsewhere, but they lacked technical know-how. So they didn't know how to implement it. So coming from the Indian perspective, yes, I agree with both Shakir and Mr. Way that there should be someone who has to champion this. And so you need champion, number one. Number two is it has to come from the highest level, the ministry. And so the imminent part, the impending part that I believe was required, that there was a directive that was coming out. So I was called for to provide a testimony. So we did that with evidences coming across the world, and it worked really well. And one ministry didn't agree, but the other ministry agreed. For example, in India, what happened was Ministry of Road Transport and Highways, which dealt with all of these, they didn't agree on this, but Ministry of Environment, Forest and Climate Change agreed, because that is coming from a sustainability perspective. So they talked to each other later on, and you saw the video yesterday, both ministers talking. So we had to call both of them on board, and they were both of them are aggressive, which is a good thing. So we need a good leadership at that level. And then we also need this research to practice. These three are very important at all stages, from academia, from industry perspective, and then also from the ministry, from the admin.
This side of the table want to say something?
Yeah, just quickly, I think one of the shortcomings we have in the field is for this specific rubber or dry rubber, not everybody has a specification that can rely on and move forward, not all the states. And some of the states that I've been in multiple states before I end up in Arizona. So some of the states I know they tried and it failed. And that will never come back, or it takes long, long time to even look at it again. So I know at least 3 states that I talked to, and they had done it. They didn't like it. They failed, and so forth. So that's one. And then the question is why they failed. Did we not do our job well? Where didn't we prepare before we go out and do it? So that's a question, I guess, for more seasoned folk here, that why it failed. And then the second, I think, why part is our industry is cost sensitive. So if we had customers who came to our door and wanted to do rubberized asphalt, and the first or second question was how much it costs. So if we are so adamant that this should be widespread, can we work to bring the cost on? And I sort of talk a little bit in my talk that there is two things that is still standing out. We all proven that it works, at least up on the gate. It says it's higher cost, higher emission than the conventional. It's better performance, but that's long term. If the EPD is stopped at the gate, then we have to do a little bit legwork to bring it down right there. So when the customer comes, we don't offer a higher price, because it's very low margin industry and very risk reverse.
Yeah, I had experience, not directly, when I was an assistant professor 30 years ago in Arkansas. Arkansas DOT did an asphalt rubber project on an interstate, and it did not outperform traditional method, so they gave up. So when people had bad experience, it may not be the fundamental reason. Maybe it's a mixed design problem, maybe it's a construction quality problem. But it didn't perform as expected. So it's very hard, as the other guys mentioned, it's very hard for the management to come back to reinvest or do an investigation to see what went wrong. But in any kind of technology, in this case is material science, materials engineering. In my case would be technology development. Champion is very important. Several of us mentioned we need to champion. I'll tell you, like the technology I developed in the last 30 years, throughout the 3-decade time, I always relied on champions that came out from the audience, from the community, somebody I'd never heard about. They said, I read your paper, I attended your presentation, we would like to use your technology. And sometimes they came to me with the funding already set aside to do it. So we need a champion like that. An example that we see here is George Way. When I was working for him, anything I needed, he was able to get it for me, even though I was not asking for millions of dollars, but it's really above the regular state employees' budget to, like, I need a very high-end computer. You guys probably wouldn't know at that time a 486, which had the fraction power of a cell phone computer today. It was $6,000 without the monitor. It's $6,000 a desktop, a 486DX with a math coprocessor. I need the math coprocessor to do the linear programming and Markov analysis. So George just say, I got money for you, it's ordered, it's compact, it's $6,000. That's like 35 years ago, guys. It's like $20,000 today. It's a good amount of money. So what I meant is if people had champion, had mentorship, things will go along, and eventually we will advance.
Thank you. George, do you want to make a question?
Yeah. Good question, yeah. Of everyone here, I think you started out with an excellent question, not just for asphalt rubber, but for everything that people on the panel are doing or have done in the past. But I'm thinking more like in the future, because, the past is the past, okay? And I agree with Camille, we don't really need to reinvent the wheel or the rubber meets the road or something like that. But we have to integrate into the future, I think, as Ellie said, there's the framework has changed now. The world now is committed to sustainability and circular society and all of this, and that's all great. That's where we ought to be going. And I would like the view of some of the others here as to how that integration can operate and how asphalt rubber can kind of sort of be a reinforcing, because as George Souza's done a lot of research in this area, showing, the savings in resources, the savings in CO2. The other, someone said something about engineers are supposed to be minimizing cost. And I had a boss once, and I came in with this great design. I thought it was really good. And he asked me about it, and I'd been using a lot of average figures, average this, average that. And he looked at me for a while, and he said, "Why do you use average?" I said, "Well, that's what we do, He says, "Why can't we go above the average? Why do we have to stick with average?" And I said, "Well, we don't have to. That doesn't say any place we have to." And he said, "Well, then don't. Go with what you think is right. And let's see what happens, And that's it. We somehow, AASHTO Pavement Design Guide, wonderful guide, but it's got all of these things you just plug in. You plug it in, plug it in, plug it in. But then you have to ask yourself, I just plug some things in. What does that actually mean anyway? And that's the point, to think beyond just all of those. Because as they will tell you, these are default values, guys. These are default values, which means they're only good 50% of the time. The other 50%, they don't work. That's not too good. It's not a good average. The bridge designers do not operate that way, I guarantee you. They are working on a 100-year life cycle, a 200-year life cycle. They're putting their foundations down to the bottom of the earth, They're not taking any chances whatsoever in a bridge design because they don't want to ever have one fail, not while they're alive. After they're dead, it might fail. But pavement designers and pavement engineers, we're up against this. We got a minimal amount of money, a minimal amount of thickness to deal with oftentimes, and we're supposed to do magic, okay? My point here is to think in the world that we're going into, where resources are, important to deal with, obviously, but they're not, going to be there forever. As somebody said, that someone said before, I think it was Trenberth, somebody said before that, resources would begin to run out. So it's a matter of making everything integrate together and how each one of you, I'm asking all of you to think a little bit beyond just, we want to put down a little bit more rubber or asphalt rubber, but how do we get it to where it all comes together in your vision of where it might be. And then again, maybe you don't have a vision, which is okay. But that would be my thought is I'm more of a future type guy. I've always been that way. And, how long is this going to last and so forth. And with Kelvin, I love what he said, but my experience was that we follow a pavement for 3 years or 5 or whatever, but we never get that whole picture. And standardize in a way so we can say we're absolutely sure this is how it mapped out over 10 or 20 or 30 years. We don't have a lot of evidence of that. We have a little snippet of it, 2 or 3 years here, 4 or 5 there. But it's because 2 reasons. 1, we don't have a standard collection system over and over again. And 2, we don't stick with it. There's no payback to an administrator who says, oh gosh, we followed this pavement for 25 years. Somebody out there is going like, well, so what? It's that kind of a thing where you have to get beyond it. Thank you for reminding me. Anyway, I'll let each one of you, however, maybe we should start with, I'm going to start with the guys who are the youngest and let them start because the future is out there for them. And that's older guys can, and so maybe, I don't know which one is the youngest here. Which one do you think's the youngest? You want to take a vote on it here or whatever? Well, I know she's the prettiest. That's for sure.
Yes, go ahead.
Thank you, George. Thank you for the compliment. Well, this is actually it's touching my heart because this is a question I always think about. Like, what can we get out of our molecules or our building blocks? What else we can get out of them? So when I sit here and hear you guys talking about all these good things that the rubber does, I always think like, what else? What else it can achieve when we put it there? As much as I love our AASHTO and SuperPay PG and all these specifications that we have, they are a little bit bonding because we learn to do a pass or fail. Like we have this criteria. Did it pass? Okay, good, thumbs up, we move on. But like, I love the way you pose it. There's so much more we can think about it, and I actually dare all of you to think about it that way, that how we can reach the max, not just the passing criteria that the specification tells us. And well, maybe I think a little bit different because I think of molecules and chemistry all the time, and I see more possibilities. But when I look at rubber, for instance, I brought it in my talk that people say rubber has high emission. On the other contrary, rubber can be an adsorbent. So you can actually help reduce emission instead of thinking as, oh, it emits this toxic. No, it can actually reduce emission of current asphalt, which we haven't looked at it that way. But so back to your point, George, I want to actually tell all the audience, this is sort of call for action. When you get to lab or to your research next time to look at how this material, this recycled material, I don't like to call it waste, this new material that is left over somewhere can be factored into payment. Don't think about how can it just meet the criteria and not fail. Think of it, how can I improve? Yes, we are improving carbon. We are reducing carbon, that's good. But what else? Because we are engineers, we want better road. Reduce carbon, but also get better performance, better functionality. Some functionality that may not be there. I went to this asphalt for roofing and roads, so sometimes we use asphalt on the road, roof as well. And we were talking like really crazy ideas that roof can be multifunctional roof. It doesn't have to be just covering our head. It can be other things. Same thing with road. And I love the idea George brought up, I don't know, solar panel. Think of it like big time. We have these assets. What else we can do with it? Yes, it drives the cars, but what else we can get out of it?
Yeah. Can you, yeah.
I would go with 2 or 3 points here. Number one is, yes, it's important that we have to start thinking disruptive, but we also have a two-pronged approach here. One is to upscale. The other is downscale. So we have to start looking at a rubber particle, maybe nano level, that can be expanded to become a road for us, or look at a road that can be studied micro level. So upscaling is actually easier. Downscaling is difficult mathematically. But what we should be doing is, if you have to talk about disruptive, this is what we should be doing, either do this or do that, depending on the situation. If the project demands that we come back and then redesign some of the things, we will have to downscale, which actually is difficult. Upscaling is easier, as I mentioned, but for all of these, we need some resources. And we have the software tools right now. I don't think we have any problem. There's no dearth for software technology. So that's number one. Number two is how disruptive, how much disruptive? Can we stop it somewhere? How much enough is enough, right? So I go back to what Ellie is saying. Yeah, we can start thinking of something that is not even there on paper right now. I still remember our discussion 15 years ago with Mr. George Way. He was asking me, can we actually find the viscosity of a tissue paper? You remember this discussion? So we haven't even thought about viscosity of the asphalt mix today. We've always talked about viscosity of the binder. We don't talk about the mixture. Right, so there are difficult situations, and again, I go back to this, upscaling, downscaling has always been a problem. Product development and product implementation, both of them with the risk. I think that's where that disruptive is. Yes, can it be a the next point is multifunctional approach, or multidimensional. Should we use the road that could encapsulate? So Professor Kalush and I, we have a project together. We are looking at the roads charging the vehicles. We don't want to have a charging station somewhere, creating range anxiety. But there is so much of loss because of this. So we need to be containing those. So can we have rubber do this job for us? Rubber can be an insulator as well. So we need to come up with some technologies. Again, it is open to every one of us. But yeah, that's where I can think of many things, but maybe I'll stop it here. You're the youngest.
Can I give a different angle on all of this discussion? I think this is great, great input. But going back to what can we do in the near future or maybe in the future. Based on my recent experience, recent past, there is a sense of lack of technical support in the community. That means people are willing to be champions, but they just don't feel they have the technical support group, worldwide, I mean, at least in my community, to support their efforts. So one challenge for us as a group that we meet every 3 years or so is how we can go back and think about ways how to institute, create technical support groups that can be driven to support these policymakers and perhaps change their mindset. So that will be, one aspect. And we can kind of complement that with, instead of meeting every 3 years, one meeting, come back and share all the great work that we are doing, how we can disseminate that types of material into some training programs. And I agree with Krishna, higher up coming down is great, but honestly, I feel that if we don't invest in the young people right now, for the next 25 years we'll be sitting the same thing, or maybe some of the younger ones will be talking about the same stuff. So we need to kind of go in between, or maybe address in the youth, different programs, as low as middle school is not really that far off to talk about these types of environmental benefits and good things and recycling. Couple that with some training programs and technical support groups that people can, hey, I can, in Portugal, I can go here, in Arizona, I can do there, in Germany, I can do that. So, and I know it's a big task, but I think we have to start thinking along those lines. So that's my contribution to this discussion.
Okay. Well, my contribution is from the experience we've had in California. So when we started the rubber evaluation, it was in the 70s. And we had to put test sections, and we had to wait many, many, many years. It just takes a lot of years for us to develop a conclusion about the performance of certain types of products. Then we start thinking about validation. Can we do something validation quickly? So we got the accelerated pavement testing machines from South Africa, the heavy vehicle simulators. And we start doing the validation efforts quickly, so we can do it in months instead of years. So I think we need to develop tools that can help us evaluate and validate our concepts pretty quickly, because we don't have the time to wait many years to actually come up with a conclusion. So we need validation methods. Validation methods not only for accelerated pavement testing, but other ideas in terms of pavement condition evaluation, tools that can actually help accumulate that experience in a very short period of time. We are in times where people don't have actually enough attention to things. So we need to be quick. We need to validate quickly and give conclusions. If we can do that, we can actually speed up the process of implementation and develop experience quickly with the new processes and design methods, and optimize our design methods.
Kelvin.
I think I'm on. I really agree with what Camille said about support, institutional support. When I was a graduate student, the first class, I remember Professor John Zanuski, some of us knew him. He said the return of investment to do pavement research is less than the garbage industry. So if you are in pavement, if you think this is an issue, you probably quit right now doing something else. It is true, if you look at the how much money federal highways in the US and state DOTs and also in other countries, people put into research. It's not a whole lot. And then you find out the Danish government really directed long-term research into payment evaluation, FWD, now the TDS, TSD, which is getting popular. They all came from Denmark, which has a population of 5 million, I believe. And then the US did not invent any of those. We probably played a good role in the profile, but IRI was defined by the World Bank. It's not by the US government. Of course, Federal Highway took over, and then it did a lot of technology development. But just for profiling, and it's an interesting observation that is how to use limited resources to attract young people with talent to stay in this industry. It's a big challenge for universities right now. Most of the public schools in the US have some sort of payment program, probably the same for the other countries. The key is, do all the kids go to AI now? Now people in computer science couldn't find jobs because a lot of the entry jobs are taken over by AI. You guys knew about this? Just last week or so, there's a very famous computer science professor from Berkeley. He said, just 5 years ago, all the computer science graduates from Berkeley, they got multiple offers, like 5 or 10 offers, very high offers. Right now, a lot of them couldn't get a single offer, just starting from last year. It's kind of weird, but the industry is going very strong. AI is like they're spending billions every day, but they're not hiring simply because the entry-level computer science people are not needed anymore. So the people in the 30s and the 40s, they make a lot of money, but they're not hiring 25-year-old anymore. So it's changing. I believe university people like us as a faculty and also people are trying to get into colleges. The situation is changing very rapidly. We don't know what's going to happen in the next 5 years. So people still need payments. That's the good thing, right? Airfields, highways. I think there's a lot of there will be a lot of new opportunities coming up, a lot of unknowns, but we should get ready to face those unknowns. And I believe the universities and also institutions have a lot of responsibility so that we do not have a scenario 5 years down the road that half of the engineering students or disciplines couldn't find jobs just because entry-level positions, not only just computer guys, maybe general engineering, are all taken over by AIs. Is that coming? We don't know. And it's a very dangerous situation, to be honest.
I agree. Well, does anyone from the audience want to raise a question? Yes. Could you?
I would like first to thank all the organizations for the very nice conference and very good one. The key speaker and keynote speakers, really, we enjoyed a lot and we learned a lot. But there are still 2 items that I'm concerned with, really. I tried to get an answer from all presentations these 3 days. I was present in all presentations, but unfortunately, it made me more confused, which I am going actually to ask you, what's your solution for that? You see, about the binder content, when you use the rubber. So there were people such as Professor Santagata was saying that I am in the range of 4%. There are some people who are around 7%. I mean, continuously, graded mix I'm talking about. And also SMA is more or less the same, probably a little bit on the highest range. You see, I'm not sure. Somebody has used Marshall mix design, somebody used super pave mix design, somebody was talking about balanced mix design. Actually, I was present in 2017 when you made these sections, and it came to me that it is too rich of bitumen. And now that I walked in, I saw some fatting up. I mean, some sort of bleeding on the road, this section. When you go, you can see, you can judge. Although this is not under traffic. If it was under heavy traffic, obviously we would have more problem of fatting up. So my question is that what would be the best mixed design method for asphalt rubber mixes? Which of these three could be useful? Is there another mixed design for that or no? This is one concern that I am asking if you can give us some answers. You see, these are questions that are asked from us. I am a university professor in Iran, but I am consultant. I mean, you have seen, I mean, there are contractors, consultants, and so on. They saw us as people who come to Europe, to US, here, there, and we see the things. So they get consultancy from us. We have these problems in Iran, really. We have made some sections with asphalt rubber, also with RAR-X we did, and we have these problems that I mentioned. So this was one question. The other thing is about the stripping, actually. Once you put the rubber, obviously you replace some sort of, I mean, some either aggregates or the binder or whatever. The mixes come to be less resistant to stripping. Even if you go walk around here, I mean, going up these sections that you have seen, the places where the water used to stop, you can see some sort of stripping. So what would be the best item? You see, in Iran, 1 kilo of rubber comes about 50 cents per kilo, I mean. 1 kilo of polymer, SPS, it comes more than $3. So it is very promising to use the rubber rather than going towards SPS and so on. But SPS, well, it doesn't have these problems that rubber mixes have. So I'm asking what would be, it's not, I mean, it's not really justified that we make it so cheap, the asphalt rubber. We can make it, I mean, a bit higher, less than the polymer modified, but a good mix that could resist stripping too. So what would be the best additive that we can use in that? We have seen many people using different things. I mean, the 1% lime that probably Europeans have suggested is a general item. We are using some aggregates which are actually of lime type. So it's no nonsense to use 1%. Once you put this lime, you make it more stiff. And when it is more stiff, in the winter you have problem of actually thaw and freezing and
finish,
so on. Sorry.
Sorry, because
Can I address
we will not.
few
Will you want? Okay.
very fast? Okay. The road you see there, with what you call bleeding, is not bleeding. It's the fact that when they were making this mix, the temperature went to 220, and the rubber got completely destroyed. So when the rubber destroys, it releases its own oil. So that is, and that's only on one lane. The other lane is good. Answering your question, I'm very confident, and I can translate to you and send to you, that the Portuguese specifications that have been adopted by now to include rubber in pavements address all your issues. We use the Marshall test to find the optimum binder content, but, and this is very important, they keep asking, what can we do to see if the future is good? Do the test now. Test for fatigue. It tells you a lot about the quality of mix you have. And test for rutting, test for moisture damage. These tests have a good correlation to the performance. And you are right, many pavements with rubber, they exhibit, what you call it, stripping. Why? Please, please, please. Rubber as a surface area 10 times of an aggregate. That thing is like, the aggregate is like a cube, pretty much. So in our mind, when we are putting like 5% or 4% or something, we are covering cubes. The film thickness, someone addressed it, is very important. The film thickness must be measured. When you put rubber, if you don't put more rubber, more bitumen, you don't have enough to cover all the little things on the rubber. So the best solution is I'll send you, translated into English, the Portuguese specifications, which I'm very confident address everything. Actually, we have done pavements in here since 1999. They all perform great. The last one, you.
Now we have a person.
I want to
You don't want to?
Yes.
I'm going to address this. First of all, in California, we have a lot of experience of rubberized mixes, and we don't see bleeding problems. I want to address that issue. When we did a lot of the evaluation, sometimes you might see fat spots, but that's not bleeding, okay? Rubberized mixes may show some fat spots, some areas, but that's not bleeding. The other thing, using lime, and we've tested lime with rubberized mixes. In fact, yes, we've seen increase in stiffness, but at the same time, we've seen increased fatigue life. In fact, hydrated lime, when you're treating the aggregates with hydrated lime, definitely you're going to have a higher stiffness. So that's a good thing. A good thing because you also have a longer fatigue life. Lime contributes to a longer fatigue life. Sometimes higher stiffness does not mean cracking problems and does not mean shorter fatigue life. That's the testing, the extensive testing we've done actually showed that. Sometimes it may be anti-intuitive, but performance speaks for itself. The rubberized mixes typically have high binder content because we use gap-graded mixes. So there's room to fill those gaps with more binder. So even about 8% binder compared to conventional mixes, which are about 5% binder. So you're increasing the binder content, you're increasing the flexibility, and also you're not compromising the performance. In fact, you're increasing fatigue life.
Can I just add something? We should remember that in principle, we are also reducing the thickness. We're not just increasing the binder content, but we are reducing the thickness and enhancing the life span of the road. So we can also look at it, we are saving aggregates because, okay, we are using a little bit more binder, but less thickness and during a longer time. If the thing is properly done, of course. I'm not saying all the time that we get this result, but that's, in principle, that's it.
Good point. Yes. Yeah,
Thank you for providing a small example of what I was talking, technical support groups, right? If you are confused, Amir, about it, just imagine all the other public figures. So a solution for this discussion is to take the knowledge that Shakir and George and everybody have, and let's develop an AI simulation model, algorithm, that can provide solutions based on some good experience, good input. So where the future is let's use some of these technology right now. It's not that difficult to do, but we need to find ways how to integrate that great knowledge, great experience into effective way to communicate it to the future generations or even existing generations right now. So I was just going to add that to the discussion.
I'm going to get a little off subject here, but I'll come back to what your concern was. Certainly, historically, asphalt rubber has suffered because it didn't have a, let's say, an ASTM AASHTO approved design procedure, and that creates some issues. But I think what George has done is exceptionally good and gets past that. It's a workable specification that addresses performance. But I want to backtrack just a little bit. In about 1988, 87, there was something called the Strategic Highway Research Program. It was $50 million that was to really solve the world's problem with pavements and so forth. Just a few comments, because I served on some of the committees, many of them. In the beginning, they were going to solve the chemistry of asphalt. I don't know if you know that or not, Ellie. And the only thing that came out of that was a wonderful report, and the guy came up with something called amphoterics. I don't know if you know about that either, which everybody immediately burned that report. And after that, they didn't want to talk about the chemistry of asphalt at all, because industry, meaning the refining industry and the terminal supplier industry, they don't want to mess with the chemistry of asphalt. Now, they like plastics and they like polymers, because they make money. We're not supposed to talk about that, but they make money, a lot of money from it. But re-engineering the asphalt, they don't make any money. In other words, buying polymer, they pass that cost on to the contractor, who passes it on to the state, and everybody along the way makes 5, 10, 20% profit. And you know, they really like that system. Now with rubber, nobody seems to make money. I know that for a fact. I know George doesn't make millions, that's for sure. So that's another thing. In the beginning, they came up with 2 predictive tests for cracking and for rutting. And George was involved in that. It was A003. I was on that committee. And after years of convincing themselves a 4-point bending beam test is a perfect test, they ditched that test and went to something called an axial test, which doesn't work. But that's just my opinion, okay? But the test that they actually invented and spent millions on in the United States, they said, oh, that's too complicated. And I could spend hours on that. But the simple shear test, which is a great test, in my opinion, and we did a lot of it in Arizona, they also ditched that test too, even though it was proven. So, you know, you ask yourself after a while, what is it with the United States of America? And I think I think you stumbled into this a little bit ago, Kelvin, is we are many times very foolish about the way we look at research. If we can't see a dollar sign out there beyond it in our country, we ditch it. And then another country comes along and they grab a hold of it, and I could give you dozens of examples, and they make billions. But it's because the decision makers said, well, we sort of have an industry okay. I mean, why do we want to do this? And if you don't believe me, Edison invented the light bulb. And he went to the city of New York and said, I will light all of New York at my expense. But the gas industry already lighted New York with gas lamps. And they said, well, that's a bad idea. You know, this has never been proven. What do you mean he can light the whole city of New York? That's ridiculous, you know. So the city said, we'll give you can use your money. The city of New York said to Edison, you can use your money, his private money, and we'll give you a permit for 1 year. And at the end of 1 year, if you can light the city of New York, you're good to go. But if you can't, you're out of business. They shouldered it all on him. He not only invented the light bulb, he invented the generator to make the electricity so he could produce the electric light bulb. You understand what I'm getting at? But that's the way we are. Some industries have a powerful influence on our government. And if they want to go in a certain direction, they go. And if they don't want to go that way, it's really, really difficult. And you're right about AI. AI is coming, and somehow we need to get involved in it. But my point is, I agree with just exactly what Camille said. We have a lot of information, and I liked what you said about one thing going to 128. Why couldn't you take all this information and through some structured AI or whatever, say, okay, we have this information on how it performed for 1 year, and we got a little snippet here about 5 and one about 10 or whatever, and through some kind of learning process, create a first-generation model, is what I'm saying. Anyway, that's my little part. I kind of got off the subject a little bit, but I don't care.
Okay, so I'll propose that anyone wants to make some kind of final statements. I'll just make a round here because I think we are already behind schedule.
That's okay.
Shall we start this side now? Because
Yeah, that's great. Well, first of all, it's the first time for me to come to the Ask for Robert Conference. It's a very good experience. Looking forward to participating in 3 years in India. I have embedded myself into technology development in the last 30 years, not much on the material side, but on the peripheral side that's relevant. I believe technology is advancing at a very fast pace. Even if AI stalls, people will do something else just because there's so much money involved. If you read the Wall Street Journal or just following the technology trends in the last few weeks, few months, they are investing literally billions a day among all the giants. We don't know where the money coming from, but that's what they're spending. Spending like without tomorrow. They're buying each other like full circle. Like if you follow NVIDIA is buying AMD and investing in OpenAI, and they have strange connections with Elon Musk, and then you don't know where those billions are going. So future is unpredictable, but the changing is coming, and I hope especially the young people here or mid-career people getting ready, getting prepared. So when it's here, you're ready to take advantage of it.
Okay, Ellie, do you want to say something?
Sure. I like that the committee this year actually have innovation award, and I encourage, and I think this is something that aligns with what Kelvin said. Now AI enables us to all become inventors and think out of the box. So even if you haven't had a single course of chemistry or haven't thought about chemistry, AI can help you understand more about your asphalt and rubber and what you're doing. So I encourage everybody here, just don't shy away from the molecules and chemistry. Just delve in and help innovate. And in this industry, if we can offer part of RAR Conference and Innovation Award or encourage innovative mindset, I think we can go faster and reach more.
Exactly. Well, what you guys want to say? Yeah?
Yeah, I think the technology is moving so fast with AI now. I think we need to look at AI as another tool that can help us, gives us more arms to work with. And it will actually increase our capabilities. Using our own brains, increase our capabilities in producing much more than what we were able to before. Regarding the technology and implementation, I remember I saw a movie called Who Killed the Electric Car? This was in the 60s that they developed there was in development of the electric cars, but the oil companies stopped it in its place. It took so many years until recently we started having the electric car. So we have to be aware of the lobbyists and the industry control over the implementation of new technologies.
I believe the future is bright. It's going to be great, okay? So despite all this criticism and the pessimistic view that you might hear here and there, I just look back in my career in 35, 40 years, in the industry, well, we have come a long way. So even though we complain a lot, but, the future is great, especially when I see the youngsters presenting nowadays, the young folks, researchers, engineers. I can't imagine back in our days we had that type of talent. So just looking around, just seeing that youth and knowing that we have all this technological advancement and the tools, I think we'll be ramping up much faster. So congratulations and good luck.
So I get the last word.
Yes.
Okay. May I propose three things between now and the next RAR 2025
RAR2028, taking back all of these suggestions, advice. Before I welcome you to India, maybe we should be prepared to go to India. Not the visa or the technical or the admin things, but maybe we should start a task group right away, formulate a task group, maybe multiple ones, and have capacity building done starting as early as next year.
For the next 3 years to prepare people for three things. One, innovation. Two, technology transfer. It could be international, it could be national, it could be state level, county, whatever. Three is startup and entrepreneurship. Because there is that, the youth has that power, rightly mentioned. We need to be encouraging startups, and it could start from the non-profit organizations as well, just to give them an impetus. It doesn't have to be financial support, but at least the technical support. With all this, I think we will be ready, and for sure we'll be welcoming you to India. Formally, we'll announce that soon. But thank you very much once again. It was a pleasure coming, and we are now in the 25th anniversary, so the next 25 years should be on towards that direction. Thank you very much.
Thank you very much for all your contributions, and we look forward to the next 25 years. First, the next 3 years in India, and then we move. And of course, the future is bright, as some. They're kicking us out, I think. Okay, let's go downstairs, and thank you very much once more. Can I just ask for applause to our panelists? We finished. Thank you very much. They kicked us out. I think we should. Let's move.
So before you leave, I just want to give you a 7-minute video of what's going to be the tour, the history before the tour you're going to see tomorrow. You're going to see it tomorrow, so no need to sit. But for those that are not going, this is an interesting summary of what happened in the roads that you're going to see tomorrow.
We're proud to present a sneak peek and key information about our upcoming Algarve trip. End-of-life tires represent a global waste challenge. Each year, millions are discarded. Traditional disposal methods release emissions and consume resources. But innovation is changing the way we build roads, turning waste into performance. RAR2025, Sustainable Roads for a Greener Future. This is more than a damaged road. It's a reflection of the challenges we face in preserving our infrastructure and our environment. Every crack tells a story of wasted potential, an opportunity for change. Addressing damage like this requires more than just patching and resurfacing. It demands innovation, innovation that extends pavement life and reduces environmental impact. The result is a modified asphalt with improved elasticity, higher resistance to cracking and deformation, and superior performance under heavy traffic and temperature variations. This is the reality we find on many sections of a road network. Damaged pavements, cracks, loss of grip, and structural degradation. Each visible defect represents not only a safety risk for road users, but also a waste of resources and energy. When traditional repair methods require full material That's why we seek smarter, longer-lasting solutions with a lower environmental impact. Approaches that reuse what we already have instead of simply discarding it. The use of RAR, reacted and activated rubber, represents a significant step in that direction. An innovative additive that enhances asphalt performance, increases pavement durability, and promotes a circular economy by reusing recycled rubber. CO2 reduction analysis. Milling and transport, the SMA-10S solution generates zero emissions in this phase, as no milling is required. Mixed production, transport, and paving process, due to the reduced layer thickness, emissions across these stages are approximately 2.5 times lower compared to conventional solutions. Overall impact, when considering the entire construction process, the total CO2 emissions are about 3 times lower than those of standard asphalt rehabilitation methods. Second challenge in this area, the situation tells a familiar story. Cracking, deformation, and surface fatigue, all signs of a pavement reaching the end of its life cycle. Decades of heavy traffic, harsh weather, and repeated maintenance have taken their toll. Each intervention has extended the road's life a little longer, but the underlying problems remain: loss of structure, poor drainage, and material fatigue. These conditions are not unique to this site. They represent a broader challenge across many regions, where aging pavements demand increasing resources to maintain acceptable performance levels. Whenever possible, our approach should prioritize environmentally friendly solutions, methods that preserve existing materials and avoid adding more waste to our landfills. In this project, we applied that principle in practice. Instead of removing the old pavement, we placed a new 2.5 centimeter layer directly over the existing surface. This approach minimized material consumption, reduced transport and emissions, and extended the life of the original structure. It's a simple yet powerful example of how smart engineering can deliver both performance and sustainability, protecting resources today while building better roads for the future. After completing the work, a detailed performance evaluation was carried out to assess surface conditions. Friction tests were performed in both directions and on both lanes, left and right. The graph shown here is presented as an example of the left lane in the increasing direction, but the results obtained on the other lanes were very similar. Measurements were taken using ASFD equipment, and the data was converted to scrim values for standardized comparison. The results show consistently high friction levels across the section, confirming excellent surface texture, grip, and uniformity. This proves that the pavement delivers safety, durability, and consistent performance, even under demanding traffic and weather conditions. Overall, this project represents a clear success, combining technical excellence, sustainability, and long-term performance in one solution. RAR, delivering results that stand the test of time. Over the past 2 years, we've completed 2 major projects, one in 2024 and another in 2025, both proving the efficiency, performance, and environmental value of the RAR technology. And the work doesn't stop here. More sections are already underway this year, continuing our commitment to building better, safer, and more sustainable roads. These projects are more than construction. They're a statement of innovation, responsibility, and progress. So as we set off on this road trip, we celebrate what's been achieved and look forward to the journey ahead. RAR, engineering performance, protecting the planet, and to everyone joining us on the road, safe travels.
Well, one information for you about AI. This video was done by Flip using it's the first ever presentation he did with voice and using AI. It's amazing, isn't it? I think it turned out to be very good. Anyway, gentlemen, we are finished here. It was fantastic to have you here. I heard fantastic presentations. Thank you for coming. And I hope to see you tomorrow. The lunch is also great, so just don't miss the bus. Or if somehow you don't want to take a bus, just show up at the midpoints that we have set up. And do we have the papers to give them today or tomorrow? Tomorrow we have a little paper to give you showing everything. And by the way, we made a special what do you call those? Safety? Yes, that I asked you to use. We're going to give them to you at the first stop, then use them, because it's also very easy to identify if you are not there. So we want you to use it. Obviously, we're going to have protection on the road when we get out of the road, so a lane closure, but you must use these jackets, okay? So, fantastic. Thank you so much for coming, and your presence, it's what makes this conference so great. See you tomorrow. Oops. These two?
Yes, you can send it.
Here?
You can copy. It takes time. No? It's too slow. Okay.
That's it. Let's wait a little bit. It's working, okay?
It's working,
so,
but it takes time. Don't forget.
My phone. Okay. So you arrived okay at the hotel? You're welcome.
Okay. Yes.
Tem que falar com ele. Já está tratado então aqui o senhor vai começar por esta estrutura, a ativar isto, ok? E depois vocês podem começar então por aí.
E já posso dar esse não é bom.
Sim. Sim. Pode ocupar ali o teu plano. Deixa um espaço livre só para as pessoas passarem.
Era que se via. Vamos enrolar aqui. Para vir para a rede.
Isso demora um bocadinho,
Is a,
takes a little bit. We have to be patient.
yeah, I do that. Yes, don't touch it.
If you are touching, it's the more
It is.
time you eat.
I thought it's dying. No, it's okay. I was saying it's too much. Yeah, I think
You
it's.
have already copied the things?
It stopped because it was the not space, not enough space.
Okay.
No more.
Okay.
Okay, thank you.
You have to have attention with that speaker. Don't put it in the computer.